Hello, my name is Olivier Levillain and I'm going to speak to you about binary parser generators. This is joint work with Sebastiano and Ainatoki Razomanana from Telecom Sud Paris. First, let me just remind you of what binary parsers are. I'm sure that's very useful. Okay, this is code that we need to interpret file formats and network packets. So we know that writing parsers for complex specifications is hard, especially when these specifications are ambiguous. One way to solve this problem is to use a simpler form, a simpler description to describe the format we want to parse, typically a domain-specific language. And then we can use a tool, a parser generator, to transform this description into code to generate it. And actually, this solution has already been described several times here at LongSec Workshop over the years. So one question we asked ourselves is, why do we have so many different tools? And we try to compare them using a framework, a platform, we called it the LongSec platform, we designed and implemented. The idea is to include in this platform several tools for which we will build base containers, which will allow us to implement some specifications. So for each specification, for example, Internet IP header or DNS packets, and for each tool, we would like to implement a parser using the tool for this specification. And once we have built this implementation, we will try to compare these different implementations and check how they behave. The first thing we want to check is how they behave against a set of samples, good or invalid ones, that we have been preparing for each specification. We also would like to look at the performance of the different implementation and also the robustness, because usually one thing we would like to have with these tools is to generate parsers that are robust. So the current status of our platform is that we integrated several tools. Some of them are included here, and some of them were presented during previous editions of LongSec Workshop. And we also looked at some specifications. First, we tried to work on basic constructions like magic numbers, lists, just to make sure we understood how these different tools worked. And then we went on with relatively simple specifications like ICMP, IP, or DNS. And more recently, we have been working on X509 or some more complex specifications. So first, let me present you how this platform works. Okay, first, let's look at the list of tools available in this particular setup. We can then look at the specifications that are currently described on the platform, and we will look at one in particular. This is the magic one, the magic number, which represents which is a specification corresponding to a file containing exactly the magic string. The magic string that you can see here. So in this case, we have one good sample, which is described here, and 3 bad samples, which should be rejected by a valid implementation. So let's look at one of these implementation. We have one implementation using Parsifal that's in the platform, which consists in just a single line. And we will try to look at the behavior of this implementation. To this aim, we will build the Parsifal base container, check that it's working, which is the case, and use the validation feature on the magic specification. As expected, the implementation in Parsifal will accept the good sample, which is why we have OK, and reject the 3 bad samples. Back to the presentation. We can see that we have been implementing several features in our platform. For now, the most important one is obviously the sample validation, which allows us to check the behavior and the correctness of implementations using different tools with regards to a given set of samples for each specification. But we also included some fuzzing tools like AFL and libfuzzer. For now, we can only fuzz C or C++ programs, but this should be extended soon. And we also have the possibility to use a shell to just mess around and look at the implementation and the samples do more manual work and check that we understand some particular behavior of the implementation. On the expressiveness, we tried to look at different implementations of the DNS specification using Hammer, Kite-Strict, Nail, and Parsifal. These are 4 specifications that were actually given with that came with the tools, so they were written by the tool maintainers, and we wanted to look at to which extent these different implementations describe DNS messages. And actually, DNS messages include some form of compression, of label compression, which is not always handled by the different implementations. And we also looked at the size of the code needed to pass DNS messages using the different tools. It's interesting to look at these numbers, these figures, because we see that in some cases we have implementations that are very, very verbose, but that nevertheless do not implement compression. And this is maybe something that has to do with the fact that Hammer, which is the more heavy implementation in this regard, is written in C and doesn't use an external DSL. So you have to really write some C code to make it work. On the other hand, you have Kite-Strict and Nail, which are able to express a lot of things using only description, the description language, which is an interesting way of seeing things. About the robustness, we tried especially the DNS implementation using our fuzzers, and we found some assertion failures in the Hammer implementation, some exceptions on truncated inputs in Kite-Strict, and several problems with Nail, because the code generated by Nail is not very robust. Actually, in some cases, we can get a very long loop in Nail implementations. So this allows us to check the behavior of these different tools. And in conclusion, we have been working on an open framework with several parser generators. And for now, even if we only looked at some trivial specifications, we believe that it's a framework that can help us work, experiment on these tools. And this is why we plan to add more tools and more specifications to our platform. And we would like to invite tool developers to contribute to this platform because it can serve 2 goals. The first one is to make some documentation about how all these tools and all these languages work in practice. And the other one is to be able to compare different approaches in terms of robustness, performance, and expressivity. I thank you for your attention, and I'm ready to answer your questions now.